All right, let's recap our sine rule. Of course, trig shouldn't be restricted to just right-angled triangles, otherwise, well, it's not that useful because most triangles, of course, aren't right-angled. Remember, the common way of labelling triangles, we use the capital letters for the vertices, we use lowercase letters for the sides, and we label the side opposite the angle with the same letter. Okay, the way we create the sine rule is we drop in a perpendicular line, creating two right-angled triangles which we can work with at this stage. And so h over c would be the sine of b, so I can say h is c sine b. Then in the other right-angled triangle I can say, well, h over b is sine c, so h is b sine c, but it's the same h, so therefore they must equal each other, thus creating the sine rule. C over sine c is b over sine b. And of course I could have equally have done that by drawing in a different perpendicular, and it would be equal to a over sine a. In fact, the complete sine rule is it's also equal to one further thing. Right, so the sine rule is a over sine a equals b over sine c equals c over sine c equals...
Radius of a circumcircle.
Close.
In circle.
The diameter of the circumcircle. So you guessed wrong. So diameter of circle. So if you draw a circle which circumscribes the triangle, the diameter of that circle would also be that same ratio: a over sine a, b over sine b, c over sine c. All right, let's just do an example. There we are. I've just randomly picked some numbers, interesting sizes of numbers, I suppose. So this one will be h over sine h is q over sine q. Rearranging that, we want to make h the subject. And pretty much it's just calculator work, of course. And we get our answer to one decimal place. I've done it to one decimal place. I usually just match whatever the question is. Question's given it to me in one decimal place. So if they don't tell me, I'm going to match it, because I know for sure I'm not going to get an exact answer with angles like that. 43 degrees, 26. I mean, they're too awkward to get exact angles. The other type of question, of course, we could get is to find an angle. So in that case, we usually put the sine ratio on top because it's easier to make it the subject. So this one will be sine y on y is sine z on z. Subbing in our given information. And that's sine y. So to find y, inverse sine that expression, and I have 46 degrees 58. There is a problem, of course, when we use the sine rule. Now, it's not a problem in this particular triangle, but your calculators, of course, will only give answers for the sine which are acute angles or negative acute angles. So if it turns out to be an obtuse angle, your calculator won't tell you. Now, I said this particular one's not an issue because we already have one obtuse angle, and it would be impossible to have two. So I know it must be the acute angle of 46 degrees 58, but does it make sense? The sorts of things you should be looking for. Okay? Could it possibly be obtuse? Remember, angle sum of a triangle has to be 180. So that last one there, it made sense because if I made it obtuse, the angle sum would go over 180. But always remember, the largest angle is always opposite the largest side. Okay? And also, the smallest angle is opposite the smallest side, and the middle-sized angle is opposite the middle-sized side. So that's a way of checking, well, does it make sense? Because clearly, if it is going to be obtuse, it must be opposite the largest side. And so you know a couple of the sides of the triangle, that might be able to help you. Sometimes it's not possible, and so in that case you'd have to write down two possibilities. It might be acute, it might be obtuse. This is what I was talking about with the circumcircle. So if you were to draw in the circumcircle, the diameter of that circumcircle would also equal a over sine a, b over sine b, c over sine c. Comes useful actually in some circle geometry questions. You can use that idea. All right, seeing we're talking about the sine ratio, the alternative way of finding the area of a triangle. There's just a random m floating here. It'll become obvious soon why that m is floating there. Let's create it. So I'll drop the perpendicular in. We know the area of a triangle, of course, is half base perpendicular height. Now, when we were doing the sine rule, we said, well, h, remember, it could be b sine c. So if I sub that in for the perpendicular height, I get half ab sine c. But again, I could have drawn a perpendicular from b or a perpendicular from c. So all the combinations, there's 3 different ways we could do it. Basically, it's 2 sides and the included angle you need to find the area. So AB sine C, BC sine A, or AC sine B will do the job for us. So let's just do a quick little one there. DM sine F in this case. Subbing in, it's just calculator work. Again, I've done mine at 2 decimal places because the question's got 2 decimal places. We get our area. Okay, so to say, quick recap there of the sine rule and the area of a triangle.